Assalamu alaikum. In the last lecture, we were studying about the client-server based application protocols like HTTP, FTP, SMTP, DNS. In today's lecture, we will discuss about the peer-to-peer based application protocols, and we will try to find out the difference between client-server and peer-to-peer architecture. And we will discuss about the file distribution applications, and we will see the BitTorrent as an example. So before discussing the peer-to-peer architecture, let's revise that what is the difference between the applications that are client-server based or they are the peer-to-peer architecture based. In client-server, there's always on server, but in peer-to-peer architecture, there's no always on server. In client server, clients communicate directly with the servers. But in the peer-to-peer architecture, the end systems or the peers, they directly communicate with each other. In client server, these are the clients which request the services from the server, and servers provide services to the clients. But in peer-to-peer architecture, the peers request the services from the other peers, and the peers that provide the services to each other. In client server, the servers have permanent IP address. But in peer-to-peer architecture, all the peers have dynamic IP addresses. For the large client server based applications, there are huge data centers, but in case the number of peers increases in the peer-to-peer based architecture, their management becomes very complex. So now it's clear that in peer-to-peer architecture, there is no always on server, and the end systems, the peers, they directly communicate with each other. Okay, and the peers are intermittently connected. They change their IP addresses on and off. This means there's a pair that is connected to the network with some IP, and if it will try to reconnect after some time, it might get the new IP address. The examples of peer-to-peer architecture are file distribution. BitTorrent is a very common example of the file distribution application. And the other examples are streaming or the voice over IP like the Skype. Okay, we will try to understand the peer-to-peer architecture with the help of the file distribution application. We will try to find out the difference between the client server and the peer-to-peer architecture, and we will see how the peer-to-peer architecture is more self-scalable. As we are considering the example of file distribution application, so we will try to find out the file distribution time for the client server approach and also for the peer-to-peer approach. Now look at this example, or we can look at this network model. We can see that there are number of pairs and a server that are connected to the network through their access networks. Okay, and this is the server upload capacity or the upload rate, and this is the server peer 1 upload rate, and in case there are n pairs, so this is the upload rate of the n pair, and similarly this is the download rate of the peer 1, and similarly this is the download rate of the peer 2, and this is the download rate of the peer n. As we are considering the application, as we are considering this network model for the file distribution application, so we are assuming that all these nodes or the pairs and the server, they are not using any other applications, and they are using their bandwidth only for the file distribution application. And here the network, it has the abundant bandwidth, but these access networks, they may have the limited bandwidth. As in this application, we have assumed that the number of pairs, this network model has the fixed set of pairs, that is the n pairs, and here the server, we will try to find out the file distribution time for the server to upload a file that is of size f to the n number of pairs. Okay. But here, as you can see, that if we consider the server transmission, that server needs to upload the n copies of the file f to the n pairs, because there are n pairs, so it need to upload the n copies for these numbers of pairs, or all these pairs that are connected to the network. Now, how we will calculate the time to send the one copy of the file f to the network? The time required to send the one copy of the file f will be equal to f by us. Now, f is the size of the file which is required to upload, and us is the upload rate of the server to upload any file on the network. So f by us is the time that it will take to upload a single file on the network. But as there are n pairs on the network, and for the file distribution, it requires to upload the n copies for the n pairs. So the total time that will be used to for the file distribution will be equal to nf by us, that is n is the number of pairs or another number of copies of the file size f by the upload rate of the server. Now, as the files that will be uploaded by the servers will be downloaded by the clients. So if we see from the client side, we will consider the worst scenario where as these all pairs, they may have the different download rate. So we will consider the worst scenario. For example, this pair has the minimum download rate. So we will consider the time required to download a file will be equal to f by d minimum. That is, f is the size of the file and d minimum is the lowest download rate. Now, if we put the two observations together, we will see that the file distribution time required to the n client using the client server approach, that will be greater than or equal to the maximum of these two, that is the nf by us or f by d minimum. And we can see that this time, that is the nf by us, that is the server upload time, increases linearly with the n. This means if the number of pairs will increase, this means the size of file will increase and the file distribution time will also increase. Now consider the same scenario for file distribution application, but on the peer-to-peer network. Here, the pairs that are the part of the network, they also contribute in the file distribution. Whenever a pair gets any copy of the data, it starts redistributing that data to that chunk of data to the other pairs. For example, if we consider the the server transmission time, first consider that in this case, the server needs to upload at least one copy of the file on the network in order to make that pair to redistribute that chunk of data or that file to the other pairs. This means first we will consider that what is the time that is required to send the one copy of the file of size f to the network, and it will be equal to f by us, that is f is the size of that file of size of the one file and us is the upload rate of the server. So time required to send one copy of the file to the network is f by us. And as the file is uploaded by the server, the clients try to download that file. So here we will again consider the worst scenario, as these all pairs, they are connected to the network with the different access networks, and they may have the different bandwidth, or they may have the different download rate. We will consider the minimum download rate and the minimum time that will be required for a client or a peer to download a single file will be equal to f by d minimum. That is, f is the size of the file, a single file, and d minimum is the lowest download rate. Okay. Now, as here the clients or the peers, they are also contributing in the file upload. So this means if we will try to consider the maximum upload rate, we will add the upload rate of the all the peers. So this is the actually the total of the upload rate of all the peers, that is um, upload rate of peer 1 to n. So the total upload will be equal to US plus the total of the upload rate of all the peers. Okay. Now, if we put together all the observations, we will see the file distribution time to the end clients using the peer-to-peer approach, that will be greater than or equal to the minimum time, minimum file distribution time to the end clients using the peer-to-peer approach, that will be equal to or the maximum, or will be the greater to the maximum of either the F by US or the F by D minimum or the NF by US plus the total of the upload rate of the all the pairs. Here we can see that the file size increases, or we can say the time required to upload the total file distribution time required to upload, or the, or we can say the total file distribution time will increase with the number of pairs. But on the same time, the upload rate will also increase as all the pairs are contributing in the service capacity. We can see from this picture, or we can see from the graph, that this is the client server approach, and here the number of pairs, that file distribution time, increases linearly with the number of pairs. And if we consider the case of the peer-to-peer architecture, we can see that is also increasing, but as they are contributing in the upload rate, so we can see the clear difference between these two, that the how they are contributing to the minimum distribution time. Now we will consider the example of BitTorrent, which is a very well-known example of the file distribution. We will see how the BitTorrent works. BitTorrent is a very famous example for the file distribution for file distribution. We will try to understand the basic mechanism of the BitTorrent. In BitTorrent, we can say there is a torrent, that is a group of pairs that are exchanging the chunks of a file, and these group of pairs actually make the torrent. In BitTorrent, the file is always divided into 256 kilobytes. This means the chunks that are exchanged between the different pairs of the torrent, that the size of the file is 256 KB. And the pairs in the torrent, they send as well as they receive the file chunks. In the torrent, there's a pair which is called tracker. So tracker is that pair which keeps the record of all the pairs that are the part of that torrent. Okay. Whenever a new pair joins that torrent, it can get the list of all the existing pairs of the torrent. So basically, when tracker maintains the list of all the pairs, so whenever a new pair joins in the torrent, this tracker gives the list of the IP addresses of all the pairs that are the part of the torrent. And whenever that new pair joins the torrent, it tries to obtain the list of the pairs from the tracker, and it will try to establish the TCP connection with all the pairs that are from the list of the that is given from the tracker. Now this means the basic procedure for a pair to join the torrent is that first of all we will consider that whenever a pair joins the torrent, it don't have any chunks of data, but with the time it accumulates the different chunks of data from the other pairs. And whenever the pairs joins the torrent, it registers itself with the tracker to get the list of the pairs. and connect to the subset of peers, that is, they are called the neighbors. This means whenever the new peers will join the torrent, it will try to establish a TCP connection with the other peers in order to exchange the different chunks with the other peers. And while downloading, the peer upload chunks to the other peers, and in return it gets the different chunks from the other peers. Peers may change peers with whom it exchange data, and there's a concept of chunks. This means that peers may come or they may leave the torrent at any time. Once the peer has acquired the entire file, so it may leave the torrent or it may remain in the torrent in order to upload the chunks of the file to the other torrent, to the other peers of the torrent. Now, how these chunks are requested from the other peers or the peers that are the part of the torrent, at any given time, the different peers have the different subsets of file chunks. And periodically, that every peer, for example, here we are considering the example of new peer that has recently joined the torrent, that is Alice. It will ask the each peer for the list of list of chunks that they have, and the Alice will request the missing chunks from the peers. So we can understand this example by looking at this picture. Let's see, okay, this peer has now established the TCP connection with some peers. This means now these peers have they are their neighbors. Now this peer, which has recently joined the torrent, will try to exchange the data or the chunks of data with these peers. Now assume that these peers have different chunks of data. Every peer has some subset of chunks of data with it, but consider that this has some data. I'm naming this data to understand. For example, it has 2C, 3C, and 4C. Similarly, this has 2C and 3C, and this pair has only 3C. Now the question is, while receiving the chunk of data from, these are the chunks of data of the whole file. Now, in order to download the complete file, this pair will try to receive the different chunks from the different pairs. Now the question is that what chunk of data it will try to accumulate first. It will see that it will check what are the subset of data that each pair has. For example, this has 2C, 3C, 4C, and this pair has 2C and 3C, and this has 3C. So it will check that which data or a chunk of data is rarest. Here in this case, we can see that two pairs has 2C and 3C, and the one has 3C, but there is a data 4C which is only with this pair. This means this chunk of data is the rarest. So this pair will try to accumulate that chunk of data which is rarest among all the pairs or its neighbors pairs. So what it will do, it will receive that rarest data and it will try to redistribute the data. In this way, we can redistribute the rarest data in the torrent. So we are explaining this point that Alice will request the missing chunks from the pairs and it will request the rarest first. Now we will see how these chunks are sending. We will see what is the sending file chunks, what is the procedure of sending the file chunks in the torrent. In this case, every pair acts very selfishly. For example, Alice will send chunks to those 4 pairs which are currently sending her the chunks at the highest rate. This means the Alice will unchoke these 4 pairs which are sending the data to her at the highest rate, and the other pairs will be choked by the Alice. This means, what is the meant by choked by the alias? This means it is saying that I don't want to receive these chunks from these nodes. Okay, and besides these and the nodes which are sending the data at the highest rates, these nodes are called, these are unchoked. Besides these 4 unchoked um, pairs, the alias will also randomly select another pair, which is called the optimistically unchoked pair. It will usually the pairs calculate randomly selects the optimistically unchoked pair after every 30 seconds. Okay. Now now we can say that in total every node have the five neighbors. That is 4 are which are sending the data at the highest rate, and 1 is the randomly selected. Now, in this case, we can say the alias is optimistically unchokes POP, and alias becomes one of the POP's top 4 provider, and same is the case with the Bob. Okay, and the Bob becomes one of the alias top 4 providers. This means the basic behavior of the BitTorrent is that is tit for tat. This means it will try to find the higher upload rate, find better trading partners, and get the files faster. So this is the end of our topic, and in the next lecture we will consider another example of the peer-to-peer architecture, that is the distributed hash tables.